All right, integrated one. We are going to be talking about applied linear equations. If you want to know how this breaks down, I'm going to go ahead and show you. You don't have to write this down. Don't worry. This is just a quick lesson. Linear equations. Remember, linear means line. How do I know? Look, read that. Line equations. That's what we're going to be working on. Remember, y equals mx plus b. Y equals mx plus b. The cheat sheet has been on the front of the board now since like, I don't know, October. This is our y value, m is slope, and b is our y-intercept. So we are going to talk about applied linear equations. What does applied mean? It means applied to the real world. Now, math doesn't really get real till about trigonometry and then like calculus, but we can still see like shadows of real math. So let's go ahead and talk about this thing. I'm going to talk about number one. A concert venue charges a $25 service fee plus $40 per ticket. $40 per ticket. So $40 per ticket, that's $40 times T, and additional $25 one-time service fee. It has it one times, so it's just going to be 25. How do I put that together? Well, this is asking for an equation that basically represents the cost that you may spend. Let's say if you bought 10 tickets or 100 tickets or whatever else. Is there an equation you can create? And the answer is yes. I use sometimes C for cost, and sometimes I use P for price. It really just depends on my mood. I don't know why I'm not consistent, but welcome to Mr. Warren's classroom. So on this equation, what I'm going to do is I'm going to put this together for you. I'm going to say C equals C, the total cost. If someone was to go in and buy 25 tickets, let's say, or 100 tickets, what would they do? We have to know that it's $40 per ticket. How do we write 40 times T? Well, we just write 40T, in addition to a service fee of $25. Boom. Now, this may not look very cool, but check it out. Y equals mx plus b. I have a c, I have an m, I have another variable, and then I have my b over here. I'm going to show you something in Desmos. Here's the deal. When I write Desmos, watch this. C equals 40t plus 25. Do you see that? Technically, Desmos will graph this. It'll change what you need to do. But because I like to norm on what we're going to do, I'm going to teach you how to write an equation for Desmos as well too. So what do I mean by that? Well, I mean this. I want you to change out your C for a Y, and then I'm going to equals 40x plus 25. See that? Now, I have created an equation. This is what I wanted. I want two sets of equation. I want you to give me the equation with the variables that make sense from the problem. T stands for ticket. See that? C stands for cost. And then I want you to translate it into math speak. X is the independent variable, and Y is the dependent variable, meaning the entire cost of this program that we're doing depends on the tickets you purchase. So this is the equation we have. Now I'm going to go ahead and I'm going to take you over here. If Emma spent a total of $225, how many tickets did she buy? Remember, our equation had T for tickets. So I'm going to use my equation over here. And yes, I'll show you the Desmos thing in a second. We want to know the total cost. Whoops. The total cost that she spent was 225. The total cost she spent was 225. I have another equation. C equals 40t plus 25. Remember substitution? Well, guess what? I see that C is equal to 225. I'm going to replace it. The total cost that Emma spent was $225. She spent $225, and we can insert it into our equation like this. So why is this powerful? Why does this matter? Well, because the cool part is this is how we use math to actually figure out neat stuff. So this says kind of ugly. I'll make this look a little prettier if I can. Y'all know I can't write very well. So here we have it. Now, instead of having two variables originally, we have one. So the total cost was $225. How many tickets did she buy? You will be able to have enough room on your desktop that you're working on, not your desktop, your paper you're working on. I will run out of room, but I'll erase it in a second. Remember, what I want you to do is line up your equal signs. Now this becomes a normal equation. What's the opposite of 25? Positive 25? It is negative 25. And if I do it on one side, I must do it on the other. So this ends up 225 minus 25 is 200. This cancels out, and I'm now left with 40 times t. 40 times t. What is the opposite of multiplication? It is division. So when I divide on one side, I must divide on another. So when it's all said and done, she will end up having purchased 5 tickets. The power of math, y'all. We figured out she was able to she purchased 5 tickets right there. Now, that's how we solve it by hand. I still want to show you how to use Desmos. I'm going to take you over here. She did total cost equals 40 times t plus 25. I'm going to replace this. Instead of cost, I'm going to use y. Instead of tickets, I'm going to use x. So here's what's neat. Can I put another equation in there? Well, let's go back and look. Another equation we had was c equals 225. So c equals 225. Does that make any sense? No, because we want to make sure we plug it in for the right variable. Remember what I placed my c with? I replaced it with y. So check this out. I'm going to zoom out. Do you see this black line? Do I want black line? I don't have a color. Let me see. Red. There we go. It's easier to see. Check it out. I said that y equals 225. That was the total cost Emma spent. And you can see how Desmos mapped it across the entire thing. Our purple line right here is from this equation. Look where they intersect. What do you see? When she bought 5 tickets, her total was 225. So let me ask you a question. If she spent 265, how many tickets did she end up buying? Let's go check it out. Wow. She spent $265. She bought 6 tickets. Boom. That's how this works. I'm going to model this in class as well, too. You're going to have plenty of time to get this done. If you need help figuring out the other equations on here, I have the answer key in Empower. I'll go ahead and what's it called? And number 2, I'll go ahead and just model it real quick in blue. $50 base fee, cool. Car rental company charges, blah, 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 20 cents per mile. How do I write this out? We want to know the total cost if we drive 20 cents per mile, and there's a base fee of 50. Not my best video, y'all, but I think you'll be fine. This just shows me where I got this from. And when I want to make this more Desmos friendly, I can translate this into this. And you have your line. You have your y, your slope, your x, and your b. So we'll be doing this in class today. Make sure you're able to solve these equations over here. And that's about it.